Okay, here is our video for the SHRATEY 2 notes lesson. So have both the note sheet and your SHRATEY reference sheet handy to work through the lesson. In the previous two lessons we did, both where we wrote the equation from a graph and yesterday's SHRATEY lesson, or the last SHRATEY lesson, we were working with equations that were already in factored form. And what's changed today is that we have to do the factoring ourselves first. So we want to begin by getting this in factored form. The numerator is already as factored as it can get, and the denominator, though, we can do our cross method, what multiplies to AC and adds to B. So A times C is -12, B is -4, and -6 and +2 will both multiply to -12 and add to -4. So my factored step now looks like this. And I would look to see if I can cancel any factors, and I cannot. You might feel like you can cancel the 2's, but remember, you can only cancel factors, not terms. Factors are things being multiplied. Terms are things being added or subtracted. So this +2 means that the 2 cannot cancel individually. You can cancel this group x plus 2 because it's a factor with this other group x minus 6. They're two things being multiplied together. In the numerator, this 2 is a factor because it's being multiplied by this x. So this 2 could be canceled with another 2 on the bottom, as long as the other 2 on the bottom is a factor and not a term. So since no factors cancel, there aren't going to be any holes in this graph. So then we continue just with SHRATEY like we worked on yesterday. We set the numerator equal to 0 and solve. We write that as an ordered pair and graph it. For the asymptote, vertical asymptotes, we set both of the factors in the denominator equal to 0 and solve them. Write them as equations of lines. X equals 6, x equals -2. T is for tangent roots or together asymptotes. So the x in the numerator, which gave me my root of 0, is not squared, so it's not tangent at that root. In the denominator, for the first asymptote, x equals 6, that factor is not squared, neither is the x plus 2. So both of these are not together at the asymptote. E is for end behavior. One thing I want to distinguish between the T step and the E. When you're trying to figure out tangent or together behavior, you're looking at factored form. When we're trying to figure out for the E step end behavior, whether we have a balanced top heavy or bottom heavy, we're looking at the standard form. Or like yesterday's lesson, we created the first term of standard form by multiplying all the first terms together. So in this situation, we're looking at 2x over x squared. This is a bottom heavy situation because the exponent on bottom is bigger than the one on top. That means our horizontal asymptote is automatically y equals 0. And then the y-intercept, since our root was 0, 0, our y-intercept also is going to be 0, 0, because we already know that if you plug in 0 for x, you're going to get 0 for y. So now we look at our graph and we ask ourselves, do I have enough information to get started? And the answer is no. I only have this one root. We talked about in the last lesson how the ends are always going to be some version of this L-shaped curve. And if you have a middle piece, as we do on this problem, It's some version of an x squared shape or some version of an x cubed. So I have this 1 point here. I happen to know from my t-step that it's not tangent. So I know that it's not a bounce here. So I know it's going to be an x cubed shape. I just don't know if it's going to be going through like this or if it's going to be going through like this. And the way we figure that out is we do a test point and we just create a second point for ourselves. And we want that second point to be in this middle section. To figure out how I'm connecting this current dot to another one, I wouldn't do test points out here at the ends. So I'm going to do a test point here. I'm just going to use x equals 1 because it's nice and positive. And 1 is easy to work with. So to get the y value there, we just take 1 and we plug it in everywhere we see an x. You can do this in the standard or the factored form. This is going to give me -2/15. So when x is 1 here, y is -2/15, somewhere here. This is enough information for me to complete the middle. I knew it was going to be an x cubed shape, and now I know it faces this direction. All right, so now we are figuring out the end pieces. We know it's going to be this L shape. We just don't know if it's going to be here or here on the left side, here or here on the right side. And we go to our t-step information that we wrote down over here. We said at x equals 6, the graph is not together. And at x equals -2, the graph is not together. And as a quick reminder, together at an asymptote looks like this. That's 1 over x squared. Its vertical asymptote is here, and it's going up. It's going the same direction immediately on either side. Whereas not together, an example would be 1 over x. Here's my vertical asymptote. It's going down on the left and up on the right. It's going opposite directions. So in this case, we said not together for both. Excuse me, asymptotes. So at x equals -2, if it's going up on the right and it's not together there, then on the left, it has to be going down. And so this is what lets me know my L-shaped curve is going to be in this section, below the horizontal asymptote. So we have this L shape right here, and then on this other side, at x equals 6, we know it's going to be not together as well. So if it's down on the left, it's going to be up immediately on the right. And so my L-shaped curve goes right there. All right, on this next problem, we have to factor both the numerator and the denominator. So I want you to pause your video and do that now and then come back. Okay, so here are my factored forms. In the numerator, x minus 2 times x plus 1, and in the denominator, x minus 1 times x minus 1. None of these factors in the top and bottom cancel. That means no holes are created, so we don't have to talk about that right now. For the roots, I'm going to solve each of the factors in the numerator. And write them as ordered pairs and graph them. And then for vertical asymptotes, we solve each of the factors in the denominator. Notice they're the same, so I'm only going to solve it once, x equals 1. And then for our t-step tangent over together, neither of the factors in the numerator were squared, so it's not tangent at both of those. And then we only had one asymptote. Since these factors were both the same, that is equivalent to x minus 1 squared. So that is squared. So that means at the asymptote, the graph is going to be coming together. Okay, so then for E and behavior, both the numerator and denominator are in standard form, so I'm going to compare their leading terms together. Their exponents match, so this is balanced, and x squared over x squared simplifies to 1. So that is the value of my horizontal asymptote. And then my y-intercept is where I let all the x's equal 0. And that's going to simplify to -2. So that's my y-intercept. And I'm going to go graph that. And I actually have enough information now to graph both pieces. I don't even need to do any test points. Because we just have one vertical asymptote, I have two end pieces. End pieces both have this L shape to them. And on the left side of the asymptote, I have these 2 points. My L shape is going to have to go through both of those. And then on the right-hand side, I have this point. So my L shape should go through both of those. And if you notice, that means my behavior at the asymptote is together, which is what I predicted over here when I said that the factor was squared, which means together.